The unit circle. The unit circle is a circle of radius 1 unit which lies on the x and y axis. The center of the circle is at the origin at 0, 0, and the circle is used as a quick reference to look up exact values for the sine, cosine, and tangent of common angles. The values are determined by constructing 30, 60, 90, and 45, 45, 90 triangles within the circle and applying geometry rules to find the values we use for sine and cosine. The tangent values are found by dividing the sine by the cosine. On the circle, in the parentheses, well, first let's look at the angles. You can see in the innermost ring of the circles you have angles going counterclockwise from 0 degrees all the way around to 360 degrees. Next to the degree values are the equivalent radian values. So if you look and find 150 degrees, then beside it you see 5 pi over 6. That's the radian value that's equivalent to 150 degrees. Around the outside of the circle are values in parentheses. These are points on the xy axis, and they also represent the sine and cosine values at each angle. The x value, the first number in the parentheses, is the cosine. The y value, the second number in the parentheses, is the sine. I always remember that it goes in alphabetical order. So inside the parentheses, the cosine is the first value, the sine is the second value. So find 120 degrees on the circle. Now look in the parentheses. The cosine of 120 degrees is negative 1/2, and the sine at 120 degrees is square root of 3 over 2. So let's use the circle to find some other values. Let's start with the sine of 150 degrees. So I find 150 degrees. The sine is the second number in the parentheses, which is 1/2. Cosine of 330 degrees. 330 degrees is almost all the way around. Cosine is the first number in the parentheses, square root of 3 over 2. The tangents I've written by hand around the outside of the circle just to save some time. Like I said, tangents are found by taking the sine divided by the cosine. But the tangent at 270 degrees is at the very bottom of the circle, and it says that the tangent is undefined. That's because when you do sine divided by cosine at 270, you would have negative 1 divided by 0. Since you can't divide by 0, that's why the tangent is undefined there. Now let's use radians. The sine at 4 pi over 3. So 4 pi over 3 is almost at the bottom of the circle. Sine is the second number in parentheses, so negative square root of 3 over 2. The cosine at 0, there are no little degrees there. That means we're at 0 radians, but that's the same place as 0 degrees. At the very beginning of the circle, cosine is the first number in parentheses, so the cosine at 0 is 1. The tangent at 3 pi over 4. 3 pi over 4 is in the upper left quadrant, and the tangent written on the outside of it is negative 1. So on the circle, the center is at 0, 0, and the radius is 1. So if you go to the right 1 from 0, 0, if you're just drawing on an xy axis, you're at the point 1, 0. If you go straight up, a distance of 1, you're at 0, 1. To the left, you're at negative 1, 0, and straight down, 0, negative 1. So those are points on the x and y axis. The y axis is the straight up and down, x is the across. Now to find secant, cosecant, cotangent, they're not written on the circle, but we can find them by finding their partner values. And what I mean by partner, I mean, for example, that cosecant is the sine flipped over, secant is the cosine flipped over, cotangent is the tangent flipped over. So if we can find their partner value and then flip it over, we'll have what we're trying to find. Let's start with the cosecant of 210. So I go to 210 degrees. Cosecant is the sine flipped over. So if I find the sine at 210, that would be the second number in parentheses, negative 1/2. So I flip that over, and that gives me the secant at 210, negative 2/1, or just negative 2. The secant of 45 degrees, so I go to 45 degrees. Secant is the cosine flipped over. The cosine at 45 degrees is square root of 2/2. So if I flip that, that means the secant is 2 over the square root of 2. Now sometimes books prefer that you multiply top and bottom by square root of 2, rationalize the denominator so that you don't have a square root in the bottom. It doesn't matter to me, you can just leave it. Cotangent of 150 degrees. There's 150 degrees. Cotangent is the tangent flipped over. So at 150, the tangent is negative square root of 3/3. Flip that over to get the cotangent at 150, negative 3 over the square root of 3. Now the next two are a little bit trickier. The cotangent at 180. There's 180. The tangent is the cotangent flipped over. So the tangent at 180 is 0. If you flip over 0, you have 1 over 0. You're not allowed to divide by 0, so the cotangent at 180 is undefined. A similar situation, the cotangent at 270. If you look at the tangent at 270, it's undefined. That's because it has come from dividing by 0. So we had something over 0 to make that happen. If you flip that, then the 0 would be on top, which is okay. And 0 divided by anything is just 0. So the flipped over of 0 is undefined. The flipped over of undefined is 0. Now let's look at some other characteristics of the unit circle. As I said before, it's actually on the x and y axis, and you can divide the circle up into quadrants just like we divide the grid up into quadrants when we're graphing, and it goes counterclockwise, quadrant 1, 2, 3, and 4, and it depends on what quadrant you're in, whether the sine, cosine, or tangent are positive or negative. And so in quadrant 1, all three are positive. Cosine, sine, and tangent are all positive, because in quadrant 1, x and y are both positive. And then since tangent is sine divided by cosine, positive divided by positive is a positive. In quadrant 2, x's are negative, y's are positive. So the cosine is negative, sine is positive, and when you divide opposite signs, you get a negative for the tangent. Quadrant 3, x and y are both negative, and a negative divided by negative is a positive. Quadrant 4, the x's are positive, the y's are negative, and positive or negative divided by positive is a negative. So there are the signs. The unit circle I've used earlier in this lesson, and it's also posted on Point Learning and in your notes. It has the positives and negatives for sine, cosine, and tangent written on the circle. Another thing to be aware of on the unit circle are the parts of the angle have names. The base of every angle on the unit circle is flat on the right side of the x-axis, and that's called the initial side. And then the other part of the angle that spins around counterclockwise is called the terminal side. If you have a point on the terminal side going around the outside edge of the circle, that's called a terminal point. And then you can see you have an inside angle there for this one was 45 degrees. So this example says, from the information given, find the quadrant in which the terminal point T lies. And they're supposing that the sine is greater than 0, numbers that are greater than 0 are positive, and that the cotangent is greater than 0. The cotangent is also positive. The cotangent is the tangent flipped over. So if the cotangent is positive, that means the tangent is also positive. So we just need to find the quadrant where both the sine and the tangent are positive, and that happens in quadrant 1. And that's all they want for that. For this last problem, we're going to use a couple of common trig identities. And one of them I've already talked about, that the tangent is equal to the sine divided by the cosine. The second one that we'll be using is that the cosine squared of an angle plus sine squared of an angle is equal to 1. And remember, that little symbol is the Greek letter theta that's standing for our angle. The problem says find the values of the trigonometric functions of t from the given information. The secant of t is 2. The terminal point of t is in quadrant 4. And they want us to find the values for all 6 trig functions. Well, we have secant, and it would be very quick to find cosine because the secant is the cosine flipped over. So cosine, if I flip over 2, it's a half. Now that I have cosine, I can use the identity cosine squared plus sine squared equals 1 to find sine. So filling in 1/2 for cosine, and it's squared, plus sine squared equals 1. 1/2 squared is 1/4. Subtract 1/4 from 1, and that would be 3/4. Now square root both sides. And normally when you square root both sides of an equation, you put plus minus in front. But we're in quadrant 4. And in quadrant 4, the sign is negative. So we'll just use the negative value. So the sine of t is equal to the square root of 3, and then I know the square root of 4, it's 2, and it's negative. So the sine is negative square root of 3 over 2. Now that we know sine, let's kind of circle what we already have here. Now that we know sine, we can quickly get cosecant, because the cosecant is the sine flipped over. So the cosecant of t is negative 2 over the square root of 3. So we've got secant and cosine. We've got sine and cosecant. We need tangent and cotangent. So that's where we'll use that the tangent is the sine divided by the cosine. So tangent would be the sine, which is negative square root of 3 over 2, divided by the cosine, which is 1/2. Remember, when you divide fractions, you flip and multiply, so it would be negative 3 over 2 times 2 over 1. 2's cancel. The tangent is negative square root of 3. So now we have the tangent, and the cotangent is the tangent flipped over. So the cotangent of t would be negative 1 over the square root of 3.